All right, my name is Mike Panacki, and I'd like to welcome you to this NetAlly webcast on remote network troubleshooting simplified. So what's the challenge that we're trying to resolve here? Well, the fact is that a large portion of the workforce, both in the United States and worldwide, is being asked to work at home. And that has placed a whole new set of challenges on us, where in the past, maybe a few people worked at home, maybe people worked at home, but you were in the office. That's not the case. And so what we need to do is, for this foreseeable future, take a look at how we can go in, troubleshoot our networks remotely, as well as being able to help ensure that people are getting the connectivity they need from their remote offices. So the big thing there is we're using Zoom right now. In fact, I've gone through and done a fair amount of packet analysis to take a look at what type of bandwidth applications like Zoom use. Also, I've asked a number of people that I work with that I know around the world to go in and capture their network connection for me as far as bandwidth, latency, and packet loss. Then what I've done is I've put that into a WAN emulator. So that way, the devices behind me are connected through that WAN emulator. So when we go through and I show you this, we can run this over a variety of circuits so we can get an idea of what this is going to look like. But if you're expecting people to join meetings with Teams, with Zoom, you want to make sure that their links can support those connections. Okay. Now, I mentioned questions. We've got the chat window. I know, some people like to type them in there. If you have a question, if you could type it in the Q&A window within Zoom, what I'll do is periodically I'm going to stop. I'm going to review those. We'll make sure that we get your questions answered. One of the great benefits of a live webcast. So when we talk about remote network troubleshooting, one of the things that comes up are things like network management systems. Now, in no means is this a replacement for a network management system. A network management system, and I'll bring mine up when we start sharing the screen here, something like OpenNMS. This is an invaluable tool for being able to go in and monitor the network over a long period of time, to look for outages, things like that. What we're going to look at today is how we can go in and fill the gaps that are left by many tools like that. Those gaps that are going to cause you to potentially have to go into the office or put you in a situation where you need to troubleshoot a remote site and you can't because you can't get there. There's just not flights going there. People are asked not to travel. So what we're going to do is we're going to take a look at that. Also, we're going to exploit the remote capabilities of these tools. And that is that we can remote into those tools and we can use them just like we were sitting right in front of them. So that's one of the things that we're going to go through today. So today, we're going to take a look at how we're going to use the Etherscope NXG to troubleshoot some of these remote connections. Then, we're going to take a look at how we can use Link Live, the cloud-based results management tool, to take the results from that Etherscope NXG, upload those, and then be able to access that information. So if I'm doing a packet capture, if I'm doing a network discovery, a throughput test, I can take all of that, upload that information out there to Link Live, and then I can provide that to somebody else. And so the beautiful thing with Link Live is that somebody else can log in to Link Live and pull that information down. Okay? So where are we at today? Today, it's a lot easier to ship than travel. In fact, it's always been easier to ship than travel. I can overnight some equipment out to a remote site much easier than I can hop on a plane and fly out there. In fact, let's go over here and we're just going to take a quick look. This is a little case that I put together that has my NetAlly tools in it. We've got our Etherscope NXG. We've got our, in this case, I've got my Link Runner G2, and we're going to take a look at how we can use that as an endpoint for throughput testing. I've got my test accessories. I've got my wire mappers. I've got some cables. But the neat thing is, I can take this I can close the lid on that. I can lock it up. I can put a label on that, and I can ship that piece of equipment out to a remote location, and it can be there tomorrow. So now I can start going in and troubleshooting. So what we're going to do is we're going to look at how we can use VNC to remote into the Etherscope NXG and start driving it like we were sitting right there. In fact, one of the things that I've done is I've gone in and I've tested things like I put a PPTP VPN client on my Etherscope NXG. I was curious, if I was sitting anywhere, could I VPN in to my network using something like PPTP and then remotely access that Etherscope NXG back through that VPN connection? And I can. So that means that I could take my phone, I could set it up as a hotspot, I could connect my Etherscope NXG to it, and then I could VPN back into the office and be able to remotely connect in there. So before we really get going, let's take a quick look at if I came in here, let's see, I'll tell you what, let me just do something real quick. I am going to promote somebody to a panelist, and I'm going to promote them to the panelist so that they can help me answer questions as we're going along. There we go. So Dan Klimke is now a panelist. And so this allows us to go in and set it up so that Dan can answer questions as we're going along there. All right. So let me just go back here and we'll keep talking along. So let's take a look at our Etherscope NXG and the different interfaces it has on it. Before we get going, I just want to show you physically what we've got over there. So I'm going to grab my Etherscope NXG out. So up on the top of this, and we'll zoom in there just a little bit. Up on the top of this, I have a couple of interfaces. I've got a gig/10 gig SFP. I've got a 10100, 1000, 2.5, 5, and 10 gig copper port. Woo! Over on the side, I've got a port that I can use as a wired management port, and also this will do wire mapping. So I can use that with my little wire mappers, and I can ensure that my cabling's good. And then built into this, and we can't really see it very well because, well, it's built in, we have two more wireless radios. We have a 802.11 AC radio that is our network radio, and then we have a management radio. So what this has on it is it has 4 different network interfaces, and 2 of these interfaces can be used as a management interface to connect to it. And that's what we're going to do today. I can connect. So, well, let me back up just a hair. Let's say that we go out and we send this out to a remote site. Prior to connecting it up at that or sending out to the remote site, what I'm going to do is I'm going to configure the remote wireless network on the Etherscope NXG. I ship it out. As soon as they turn it on, the management port is going to connect to that remote wireless network. Now, all the person at the remote end has to do, swipe down. It's an Android device. I can load Android apps on there, but they're going to swipe down from the top. They're going to give me that management address, and boom, I can connect in and remote into it. Okay? So let's go in, and we are going to share my screen here, and we're going to share our Etherscope NXG. Now, what you'll notice on your screen is that you can change the size of the video, you can change the size of the screen share there, get those adjusted just right. But here, we're looking at the home page of my Etherscope NXG. So I am remoted into this via VNC. And this could be locally. This particular Etherscope is sitting right here on my desk. Or it could be halfway around or 3/4 of the way around the world, which I guess would be quarter going the other direction. So it could be halfway around the world. Now, if I come up here and I swipe down from the top, what we see is it tells me right here I have multiple network port connections, and my network port connection is 10.0.11.95. So all somebody has to do is swipe down from there, give me the IP address, and I am all set to go. So now we'll swipe back up. I'm doing this all with the mouse. So I am driving this through VNC remotely. Okay. So now the first thing I want to do is make sure I have connectivity. So as far as remote troubleshooting, what are some of the questions that people get out on the remote end? Number one, I can't connect. So in this case, what we're going to do is we're going to come up here, we're going to run this auto test. Now, one of the things that is really slick with the auto test is that we can pre-configure the auto test based on where we plan on connecting, VLAN tags, whether we're expecting PoE. So in this case, what I can do is I've set up a auto test right here on my wired side of the network to say I want to connect up and I want to make sure I have PoE. So all I have to do is come out, and I'm going to hit start, and we're going to run this auto test. Now, whenever we're going in and doing something on the wired side, or when we want to do work on the wireless side beside just discovery, we're going to run an auto test. This gives us a number of things. One, this tells us, hey, here's where we're connected. We have a connection, and we could get out to key resources out there on the network. So in this case, I come in here, and it tells me, hey, I'm connected at gig. It tells me what speeds are being advertised. Now remember, I don't have to be touching the device to be able to see this information. Here, it's telling me information about that connection. It tells me that not only is my native VLAN working, but I see VLANs 10, 12, and 14 on this connection as well. And if somebody's trying to get a voice over IP phone up and running, that kind of information is really important. Here is the one that becomes so critical when we're doing remote network troubleshooting. And that is, let's say I ship this out to some remote hands at a remote site. And that person was kind of that site's IT person, but maybe didn't have a lot of experience. Well, if I said, look, I know you're plugged into this person's wall jack, but we need to figure out what switch and port that's connected to. That could be quite a daunting task, having them go to the wiring closet, trace all that down. But because we're grabbing CDP and LLDP information, this is giving me the information about the nearest switch that we're connected to. So now I know exactly which switch and what port I'm connected to. So from a remote standpoint, now I can remote into that switch and I can start making changes. I can make the appropriate changes. Let's say we don't see the VLAN that we need out there. I can go in and add that VLAN in there. And I don't have to have them tugging on cables trying to figure out where things are connected. We can see that I got a DHCP address. Now, in this case, what are things that I'm concerned about in here? I'm concerned about where I'm getting multiple DHCP offers. Somebody out at that remote office decided that they were going to bring in their own router and they're going to plug it in. They're going to add Wi-Fi or something that we can't even see because we're remote. So now they've connected that in. We can't see that. But what we do see is that a 192.168.0.58 address is being offered. So now we know that that's being offered out there, and we probably won't get a whole chance to really get deep into path analysis, but we can use this to trace a path through the network to find out where a device is located. So now I could trace a path out to that device, figure out where that is, and see what's going on. Okay. So I'm going to come back. In fact, we see our path analysis is right there. We're just going to slide up a little bit more. So now I've gone out and ensured that they had connectivity to key resources out there on the network. So this could be, in this case, we've got HTTP for Google, NetAlly. I could add zoom.us out there. And so that'll ensure that they have that connectivity out to the network. So from a wired connectivity standpoint, now I've got a connection. And also what I have is right here, we see that little link. I am linked to the network, and we're going to see where our discovery comes in. We can start telling what's going on out on the network. Now I'm going to add one in here. I don't think any of you live next door to me. And then we're going to move on here. All right. So we're going to connect up. We're going to come in here. We're going to connect to our network. So now, once we are connected to the network, we are going to be able to go out and start taking a look at what's out there on our network and how that's connected. So we'll run that test. Let's zoom in here. All right, much better. So we got connected to our AP, we got connected our channel, our AP, we got a DHCP address, we got to our default router, and so we're all connected and we're linked on the wireless network as well. So if I come back, I can now tell you that we have a connection on the wired network, we now have a connection on the wireless network, and we're getting a level of detail that we're never going to get by somebody just looking at their PC. So we're going to come back and we're going to go into our discovery. As soon as we connected up to the network, the Etherscope went to work discovering the network. In fact, up here at the top, it's showing me what % I'm done with that discovery, and I've discovered over 100. I've discovered 100 devices out there on my network. Now, for each one of these devices, I'm going to be able to come in and drill in here and start seeing where things are connected, how things are operating. So in this case, let's see, let's go back. We're going to let our discovery finish. And I'm going to click on something like my front door camera. And right here, it is showing me that that's connected to my PoE switch port Ether2 VLAN 10. So as we're going through and doing this discovery, we're using SNMP to communicate with each one of the SNMP compatible devices out there. So this is my routers, my switches, any host that supports SNMP. So now I know exactly where that device is connected up. And if I go, where are devices connected out there? Who's connected to that switch? I could now come in and say, hey, show me the interfaces on that switch. And it's going to show me the interfaces. It's going to show me if that interface is up or down. And I can see which devices are connected to each one of those ports. I can see what the utilization looks like. So now I've got this device that I could send out there. But here's what's even better. I don't have to send the Etherscope out there. If you have the Etherscope placed at your office. So we talked about the situation where I put this over here in the case, I ship that out, and I monitor that traffic remotely. The other use scenario for this is that you have this Etherscope located at your main office, and you remote into that. So now you're at home, and you're still required to maintain that remote office, that main office. So now if I have the Etherscope connected up there, I can remote in there. Now, one of the things that I can do in my configuration right here is I can come in and I can set up all of my remote networks. So in this case, I've gone in and configured the Etherscope to reach out to every one of my remote networks connected through my VPN tunnels and discover those networks as well. So in this case, if Uta that works with me were to say, Mike, I'm having trouble with a device out there on my network, through the discovery, I could come in here and I could create a number of filters. And in this case, I'm going to filter down on Uta's office. So instead of looking through 100 devices, I am now looking at 7 devices out here. And those 7 devices are the devices that are located on her subnet. So if I said, you know what, that Raspberry Pi I've got out there for doing network monitoring, what's going on with that? What's the address of that device? Here we've got her color printer. I can see that her color printer is connected to interface gig 4. So in this case, I'm able to reach into her network and see exactly what's going on out there. Okay. Now, let me just come in here and I'm going to take a quick look at some questions that have been coming through. And so let's see. So James sent out a response out there as far as what it's going to collect. That's fantastic. Is it using CDP for discovery? Not every device may have SNMP configured. Yes. So, well, what it's using is to discover which port and switch it's connected to. It supports CDP and or LLDP. So even if the device doesn't have CDP or LLDP configured on it, if we have the SNMP community string, we can then go into the device and find out where we're connected. So there's really 3 ways that we can determine where we're connected in the world, and that is through CDP, LLDP, or through SNMP. Okay. Oh, James reminded me also EDP and FDP. So the Extreme Discovery Protocol and the Foundry Discovery Protocol, and maybe even some NDP, which is the Nortel Discovery Protocol as well. So as far as questions, let's see. All right, so in this case, we wanted to test the network drop with the wire mapper. It shows all 4 pairs are agreeing the length is 13 feet. There is no link on the drop when we tested it. So in that case, let's see. Does that mean that we have a cable run of 13 feet and is not terminated at a switch? Yes. Now, here's the thing. Just a quick one on wire mapping, which is something we could do remotely if we're connected through the wireless management interface. But with the wire mapping, if I take, and let me switch my camera over here, if I use one of these little wire mappers, this terminates the cable. So what we're going to find on wire mapping is that if we have an unterminated cable, we can tell if there's a break closest to us, but not a break at the far end. But if we put one of these terminators on it, not only can we tell if there's any breaks in the cable, but we can tell how many feet out those are, and we can see that number right there. So we can tell which number wire mapper that's connected to. Great way to map out networks where maybe things aren't connected like they should be. So going back to our discovery, we have now discovered what's out there. So I can reach out through my VPN tunnels, through my MPLS connections, through my SD-WANs, and I can connect into those remote sites without even having to ship the Etherscope NXG out there. So now I get a picture of how things are connected, what's out there, how's it connected. And in this case, all I had to do is apply a filter, and I've reduced my 100 devices out there down to 7. I can do the same thing with wireless. Okay. Now, this does some very interesting things when it comes to wireless, and one of those is what is considered breaking the layer 2 ceiling. What it will do is it allows us to go in and discover on the wired side and find out the IP address, MAC address, et cetera for a device, and then at the same time scan the wireless network and then see who's associated with which AP. So now for this network, I could see who's connected out there. So in this case, I can see that I've got this Dell 2-in-1 number 1. The NetBIOS name is this. The IP address is this. The MAC address, it's authorized. It's on channel 6, and it shows me what AP it's connected to. This is what I can't get with my network management system, especially if I'm working with APs that are not using a controller-based system. In this case, I can send the Etherscope NXG out to a remote location, let it scan my wireless, do my discovery on the wired side, and I know where people are connected. I know what's going on with them. And this is where we can start really getting in to the wireless side of things. And again, this is not what we can see just by having a device that's going to use SNMP and ping. This is where we have to have something out at that remote location. So now as I switch over to the wireless app, this tool is built of a number of applications running in here. It starts showing me what my utilization looks like, my 802.11 versus non-802.11. It shows me how many APs I have, how many clients I have out there on each one of my channels. So I could come in here to channel 11. And I could say, you know what? I want to get my channel details. So by sending the Etherscope NXG out to the remote location, I'm now able to start getting in and see what's going on out here. How many clients do I have? BSS IDs, and most importantly, interferers. This is where people at the remote location are now telling us, hey, I'm having trouble connecting. Well, I can't see an interferer, but if I have the right tools, I can sure detect it. So in this case, I could say, you know, how many APs do I see out here? And it shows me which APs are operating out there. I can see the number of clients that I have out there, and you know whether those clients are connected, communicating, what channel those clients are on. And I could come in and say, do I see any interferers? Now, right now I don't. We'll see if we can go in and at least create a interferer out there, but it's giving me information about what's going on. And if I start digging into my RF statistics, it will graph this information out over a 24-hour period. So problems don't always happen when we just go look. We have to let it sit for a while. So now I could send the Etherscope NXG out to a remote location. I can remote into it. I can come in here and I can start watching what's happening on my wireless network. I can take a look at what my signal looks like, what my utilization looks like, what my retries look like. So if I'm starting to see, you know, high utilization and I see high retries, this could be an indication that I have adjacent channel overlap, that I've got a device interfering out there. I've got a hidden node that's coming in and interfering with that, where I can't pick up enough of their signal to really be able to differentiate what they're saying and know I need to back off, and they're interfering with my traffic. So I could come back, and once it fills up this graph, I can come back in and zoom into a particular time period to see what's going on. So do we have a case where at that remote office, somebody's going out and watching Netflix or doing something and using up that bandwidth? So this gives me a way that I can listen to what's happening in the air. Now, right now, you know, we've got this locked down to one channel, but we can, if we back out of here, we can have it scan through all of our channels, start giving us a high level of what's going on out there. Okay. Okay. So one of the questions, let's see. So in this case, can we go back and analyze this information later? So what we can do, and I'm going to go back to my discovery. We ended up drilling down into our wireless. In this case, just as a note, when I went in and ran those auto tests were uploaded to Link Live, and then those auto tests, I received an email as well. And I can add comments to those as far as where I took those measurements. With my discovery, before we move on to our performance testing, I'm going to come in and I'm going to upload this to Link Live. Now, Link Live is the cloud-based results management system out there. And I'm going to put in a job comment. And I'm going to say March webcast. So this is going to create a folder out there. and it's going to save that out there to that folder. And we're going to save this to our analysis files. So we just uploaded our discovery, all 102 devices and where they're connected. Now what we're going to find is not only can we create a PDF file from that, but we can download that to a CSV file. And that gives us all of our MAC addresses, connectivity. I really want to say oodles of information about what's stored out there. Now, I'm going to come back here and we're going to go to our Wi-Fi, and I'm going to do the same thing. I'm going to come up and I'm going to upload my Wi-Fi information to Link Live as well. Now it still puts that job comment in there. So all of these are going to go into their own folder out in Link Live. I'm going to hit Save Analysis. Okay. So now we've gone in and we've gotten a good picture of what's out there. Where are things connected? And that is critical to being able to go in and find out how things are connected. Now, the other thing that we can do here is I'm going to come into path analysis, and I'm going to run a quick path analysis. So now, if I came into my configuration and I said device, we're going to keep picking on Zoom. And we're going to change that to a DNS name. And I'm not really picking on Zoom so much as that is what we're using right now. And that's the kind of thing that we're very interested in. So we're going to go back. We're going to hit start. So what this is going to do is this is doing a layer 2 path analysis until it hits our routed network. Okay, so now it shows that it leaves my Etherscope NXG. It goes to my desktop switch, comes in port 6, out port 8, into the switch in my rack over here, in port 8, out port 1, into my primary router, in port 4, out port 1, and then away it goes through the internet. Now, if it does not, and I could change the port number, and in fact, if we go to our settings right here, and we said, in this case, we were testing port 80. I could change this to 443, or I could change it to any port I wanted. But in this case, we can change those ports around, but it is tracing that path at layer 2, then layer 3. So if we have something being blocked, if we have a problem, we can see where that's at. So if I send this out to a remote location, it gives me the way I can go in and see what's happening from that local device's view of the world. Nothing makes me crazier than when I call in and I say, you know what, I'm running into an issue with this. And they say, it looks good from our end. That is saying, I don't believe you. You don't know what you're talking about. This is what we get with a centralized network management system, which again is critical. But if I can send a device out to the remote end and measure from their end back, now I get a clear picture of what their view of the world is. And I know what's happening. I'm not telling them they don't know what they're talking about. We can get a view of their end of the world. Okay. Now, we have tools in here such as iPerf. Somebody asked, hey, can I tell what's slowing my network down? Well, in this case, I could come in here. I could say that I want to go in and I want to do an iPerf test. Now, you could run iPerf on a computer. You could run it on a server. If I come in and I start typing in an address in here, it's going to show me which test accessories have registered with Link Live. Now, let me just come over here. I'm going to back up over here. I'm going to take a look at the MAC address on this one real quick, 81. So I'm going to find 81 in my list right there. So I didn't have to know the IP address. I just had to know which one I wanted to connect to. So I'm going to come in and I'm going to say I need to get 10 megabits per second up and down with that. Now I'm going to run this real quick. We're going to hit start. So this iPerf endpoint could be a PC, it could be a Linux box, it could be anything running iPerf 3. So now I'm doing a throughput test out there. What I've done is I set a limit. And I set that limit to 10 megabits per second. And if I can't get 10 megabits per second, then I'm not happy. Now in this case, it's on my local area network, and I'm getting about 482 megabits per second. So that's fantastic. Boom, I just did an iPerf test. So you could put iPerf on a phone. I've got Magic iPerf running on my phone. It's a free app. I could put that in server mode, and I could measure the throughput from the Etherscope NXG out to my phone if I wanted to. Now in this case, we're going to come in, we're going to upload these test results to Link Live. Okay. Now, the performance test. This is where we can really go in and start analyzing our network to ensure that we have the bandwidth necessary to support critical applications. So what I've done is I've gone in and built a number of services. I did packet captures. I looked to see that in this case, Zoom and a Zoom meeting uses about a megabit per second. It's a good number. So then what I did is I went in and I looked at what are the service requirements for Zoom. So within here, I can define a service. And that service can go out and talk to a number of different endpoints. Those endpoints, at the right side, could be a Link Runner G2. So we have Link Runner G2s running back here. These support up to 1 gigabit per second, full line rate, full duplex. We have a software endpoint running out here. Whoa, screen went black. Bring that back up. There we go. This is the software endpoint running out there on this laptop. Now that software endpoint, that is free. You can go out to the NetAlly website, you can download it, and you can go in and load that on as many Windows 7 or above machines as you want. There's no limit. Put it on your corporate server, put the XE out there. Download that and put it on there. What we're going to see is we can use that PC as an endpoint. So if somebody's complaining that things are slow, all we have to do is have them load that endpoint, the performance reflector, on their machine. They can VPN into the office and it will show them right on their screen. Let's go back to that real quick. It'll show them right on their screen what the IP address is right in here of their machine. So now all they have to do is they just need to go in, tell us what that IP is, and we can do a test out to them. Now what I've done in this case is I've gone in and I said, look, we need a meg of bandwidth. Our loss rate, 2%. This is off Zoom site. Our jitter, 40 milliseconds. Our latency, 75 milliseconds. What we're doing is we're looking for our latency in each direction. Now with the reflector, I could go in and put in my round trip latency. So let me just show you how we change that real quick. If I wanted to change that to 150, I could come in and I can edit that. I can put in whatever value I want. So what we're looking for is our software vendor to come back and tell us, this is what I need. They'll tell you it's your network, but they rarely tell you this is exactly what we need. So we're going to come in, we're going to get that all set up. The Etherscope NXG supports up to, I believe it's 8. James can correct me if I'm wrong, but we can do 8 concurrent connections out there. So I can run 8 simultaneous tests. So in this case, I'm going to come in, I'm going to run tests out to all these devices at the same time. And we're going to hit start. Well, that's running. I'm going to take a look at my questions here. So one of the questions, is the software endpoint able to perform 10 gig tests? No, it will not. To do 10 gig reliably, and here's the thing. whenever we're doing a performance measurement, we want to make sure that our equipment is not the bottleneck. Our equipment is not the problem. So I can guarantee you, if I use 2 ether scopes or an ether scope with something like a one-touch AT 10 gig, I will get 10 gig of throughput day in, day out without a single packet lost as a result of the equipment. With the software reflector, you can give it a try, load it up on a device and see. But I would do that with a 10 gig switch I know doesn't drop packets to see what kind of performance you get out of it. So if I want to reliably do 10 gig throughput testing, I'm going to use 2 ether scopes together. And those things will pump 10 gig through there, no problem, all day long. So I was corrected, and I was afraid that this was the number, and I knew I was going to get that. Supports 4. So we can do 4 simultaneous tests. So it was 4 or 8. I decided to go with the bigger number. But it is 4 simultaneous tests. So in this case, we did 4 tests right now. And what we see is that our connection out to our laptop worked. Our latency was 18 milliseconds. Our loss was 0.12%. Our jitter was 3. That's within our numbers. 14, out to network 14, that was good. We failed down here on our 18 network. So what it does is it tells us, hey, look, our limit was 121 packets for the test. If we lost more than that, we fail. We lost 130. Our latency shows us what our latency was. And I could come in and I could see what our jitter was. So our jitter, our latency were all good. We saw a little too much packet loss. So now what do? I could go out and do a path analysis out there and start taking a look at what devices are out there along the path. But this gives me pass-fail test results to see whether I'm able to send that information through or not. And I'm going to take that, I'm going to upload that to Link Live as well. So now what I've done is I've gone out, I've done my discoveries, I've done my performance testing, I've done my path analysis, I've uploaded that to Link Live. So let me come in here. So just a couple of things. Just want to take a look. One question that came in, did I have to install the VNC app on the EtherScope NXG? No. Already installed, server's already running, it's just waiting for us to connect. Another one, let's see, can I save the test results on the EtherScope itself? Sure, you can. And you can do that if you're in an environment where, let's say that you don't have cloud access. It can be saved on the local device as opposed to going out to Link Live. So now, let me come out here. And I'm going to bring up Link Live. I've been talking about this quite a bit. We'll drag that over here, and we are going to share that screen. So now we have Link Live. So from in here, I could come in and I could go to my folders. And here's our March webcast right there. So I could filter in on that. And here are my test results right here. So I just ran that performance test, and I know that that's awfully small on the screen there, so we'll make it a little bit bigger. But in this case, it's giving me the test results for each one of those. So it put it in the March webcast folder, shows the EtherScope that ran. It said the test failed, thresholds exceeded. I can see my little green arrow up there telling me what passed, what didn't. I'm going to come over here to my analysis files, and we can see if I click on this one right here, this is going to give me my wireless discovery information. So if I said I want to view my analysis, This now gives me all that information about my wireless network. It tells me what's going on out there as far as each of my channels. I could say, show me what SSIDs I discovered out there. Show me what APs I found. What's going on with the wireless? Did I see any interference devices? Fortunately, in this case, I didn't. But this will discover things if I have microwaves, if I have other devices, 2.4 gigahertz devices out there interfering. Okay. Let's go back. Another one that I want to show you on here that I think is just an amazing thing to be able to do is let's window that. We'll just bring it up here on this screen. We're going to come back out to our home screen. So now somebody is having connectivity problems. Things are running slow out there on their network. We need to see what's going on. I could come in here to Wi-Fi. I could go in, I could say, I want to see my clients. Now, we could go in, we could take a look at our different clients. And I could grab a client out here. We'll grab this one right here. And I could drill into the MAC address. And I can click on the tools. And I can do a Wi-Fi capture on that. Right there. It does not get any easier to do a wireless capture than this. It has set the channel with the channel, all the MAC addresses. Now all I have to do is hit start. And we can see down here how many packets we've seen, how many we've captured. So what it's doing is it's writing those to memory. This has a 1 gig capture buffer on it. It will capture at full line rate 10 gig, but 1 gig buffer, not going to capture very long. But by using filters like this, we're able to go in there. So now, by sending it out to a remote site, I can discover what's out there. I can see the wireless environment. I can do a wired packet capture. I can do a wireless packet capture. I can do a throughput test. I can upload all this information to Link Live. And so now we've done our capture. I've had the person try and connect. I've had them go in, do whatever it is that they're doing and having that wireless problem. I can stop, and now I can say save. We're going to save this. It is now going to upload that PCAP file over here to Link Live. So if I go to my files, right there is my PCAP file. I could come over here and I could say I want to grab that file. So now it downloads that file to my PC. I click on that file. I open up Wireshark, and there is that traffic right there. I can see exactly my wireless traffic. I can see all of my wireless headers for both. I can do 802.11 BGNA, 802.11 AC. I can come in here and capture that traffic and see what's going on. Okay. So let me take a look at questions again. All right. So Dan has been answering questions for me. That's fantastic. We've got about 5-6 minutes to go here. I just want to go through, take a quick couple, just take a look at my notes, make sure that I've covered everything that I want to cover. So in this case, if we come back, we take a look at, bring this up. I bring Link Live back up. We'll zoom out a little bit. So now with Link Live, I can post all those test results out there. For things like my discoveries, I could say view analysis. I can come down here to my little action button. I could say I want to generate a PDF report of that. And it's going to go in and generate a PDF report showing all of that wireless information that we discovered. So I can provide somebody with that report. I can go out there. Okay. We'll cancel out of there. Now, we do see some different colors in here. Anything that is light blue, we can click on. So if I want to come in and say, yeah, I want to see, let's zoom in here, clients. So I could come into this network and click on that and see the clients for that particular network. It's going to show me the number of retries, average utilization. It's going to show what my what AP they're connected to, all of my BSS IDs, etc. And I have gone in and carefully assigned a name and authorization to each one of these devices. So now I've got a name that goes with them, so I can see what's going on in there. Okay. Problems. So in this case, let's see. If we were to come in and on the ether scope, let me we'll window that. On the ether scope, I can come in here and not only is it going in and taking a look at what's happening out there on my wireless network, but it's doing analysis of that as well. So we could come in and we could start taking a look at, let's say that I looked at channels. And I looked at channel 11, we're just going to grab 11 right now. If we had problems in here, it's going to start telling me what problems I'm having. Now in this case, things are looking pretty good. No interferers. Let's just take a look at our clients real quick, just to see if we can find one that's got some problems in there. Okay. All right. So just taking a look at a couple things here. So what can we see as far as interferers? It is going to go in and apply patterns to what we're seeing to identify what type of device that is. So with interferers, it's going to show us what our signal strength is on there. It's going to show us what kind of device that is. So for example, I've got a wireless camera that I'll fire up sometimes and it just nukes channel 1 and above. And we can use a locate feature. So I can come in here and on my wireless client, I could take and hit locate on that. And we can use this as a way to locate where that device is. And this does have an antenna connection up on the top so that we could attach an external directional antenna. So here again, you send this out to a remote location. You find that there's a rogue device out there. So now the person you're working with has a headset on. All you have to do is say, hey, I'm going to take you out to this locate screen. And you could have them, you could say, okay, start walking. Okay, I want you to stop because you're seeing the signal strength at the same time they are. And another really powerful feature of this is whatever you see on this screen is the same thing that they're seeing on their screen. So when you're working with somebody out at a remote site and you're mentoring that person, you're getting them up to speed on how to get the most out of these tools. By using VNC in here, I can look over their shoulder. So maybe they know how to do most of the things with this tool, but they need help with something. Now, you, as the lead network engineer, are able to look over their shoulder and be thousands of miles away. So we're in a case where we can't travel. And in fact, the cost of traveling is prohibitive in many examples. So being able to take and take something like, our gear that we have set up here, find my Zoom, put that in a case, ship it out to a remote site, have somebody use that to start troubleshooting is an option for being able to go out there and get information. So we have a couple use scenarios. One is we ship that out to the remote site. Another example would be we have the tester at our main office. We take advantage of the fact that it can reach out through our various network connections and discover what's out there by using SNMP to get the bridge forwarding tables, the route tables, discover the devices out there, find out what their names are. So it provides the same functionality as if you were using it from the touchscreen. So it works just as well. In fact, if I have to type a lot of things in, either I'll attach a Bluetooth keyboard to it, or I'll just remote into it. We have Link Live as this consolidation point where we can upload our test results, see what's going on, and we can produce those results in there. So, or we can save those results. So it makes working with remote hands so much easier. Now I can send them the equipment they need and I can look right over their shoulder. Okay. So I'm going to take a quick look here just to see if, so in the case, so there's some question about duty cycle spectrum. This does not display spectrum analysis information like we would see with Spectrum XT from AirMagnet. Okay, it's going to give us some high-level information. It's in there taking a look at what's happening, but I'm not going to be able to go in and produce a duty cycle chart or something like that out of this like I could with Spectrum XT. Okay. Just go back out here. So there was a question about problems. I can come in and I can set up a variety of different thresholds and turn problems off and on. So in this case, we can see, if we receive multiple DHCP offers, etc. So if we came back and I went to my discovery and I said sort by problem. Well, right now our 10 gig switch, we see one error on there. If I go to problems, it says bad subnet mask. So that is a really nice one. For some reasons, and not to beat up on people that install printers, a lot of times I notice people that install printers, if they hard code the IP address, always set it to a 24-bit subnet mask, even if we're using something else. This is a great way for us to go in and detect things like that. All right. So one last one, any internal or external LTE modem support? There is no internal LTE modem support. And actually it has a USB, it has a couple of different USB ports on there. In most cases, what we would really need to do is we could hook it to a hotspot or something like that. All right, so we have had a lot of information we've covered. I hope that this has been useful for you to see how we can use this to go out and remotely troubleshoot networks and simplify that process by getting the right tool out there. We have a tool that can do discovery, check connectivity, take a look at what's going on with our wireless network, do our path analysis, do our iPerf, do our performance analysis, and at the same time report on all of it. So thank you for joining me in the webcast today. I hope that you are all safe and sound, and I look forward to seeing you again in a future webcast.